Hey class, this is Gigi from Kauai Community College. This is exam 2 review, problem 4. It has to do with implicit differentiation. So for problem 1, for part A, we are going to go ahead and take the derivative of both sides with respect to x, because that is what we are looking for. So the derivative with respect to x. That is what we are doing here. Okay, so in this case, x is our variable and y is a function in terms of x, so the chain rule will apply there on the y, which is what implicit differentiation says. Okay, so on the left-hand side, the derivative would be a chain rule with a sum inside. So 3 times something to the second power, the derivative of that would be 6 multiplied by that thing, which is x squared plus y squared, multiplied by the inside derivative, which would be 2x plus 2y dy dx, is equal to, on the right hand side, you have a product, so I will treat 100x as the first term and then y as the second term. So the derivative of 100x is 100 multiplied by y, plus the derivative of y with respect to x is dy dx multiplied by 100x. So that's how the product rule works. We are looking at the dy dx. We're looking for dy dx. So we have to go and solve for dy dx. Now this is multiplication. So we know that we have to expand. Okay, so we have to expand to get dy dx by itself. So when we expand, we would say, well, we now have 6x squared plus 6y squared multiplied by 2x plus 2y dy dx. Okay, and here we would have 6x squared times 2x is 12x to the third. So I will have 12x to the third plus 6x squared multiplied by 2y dy dx is 12x squared y dy dx plus 12xy squared plus 12y to the third dy dx is equal to 100y plus 100x dy dx. Okay, so we notice the terms that have to do with dy dx, which would be this one, okay, and this one right here, and this one here. We'll get those on one side, everything else on the other, and then we can factor out the dy dx, and I will go ahead and do that all together. Factor out dy dx. I will have 12x squared y plus 12y to the third, and then if I subtract 100x dy dx over and factor out the dy dx, I will have minus 100x there, is equal to 100y minus 12x to the third minus 12xy squared. And then the last thing to do is to go ahead and divide by this long thing right there to get dy dx by itself. So to answer the question, dy dx is equal to, so we would say dy dx is equal to 100y minus 12x to the third minus 12xy squared, all divided by 12x squared y plus 12y to the third minus 100x. And that is our final answer. And that's the concept of implicit differentiation. We use that because, for one, we cannot solve for y by itself, or if we don't want to solve for y, but in this case, we really cannot solve for y looking at that equation from the beginning, right? So that's what implicit differentiation is. Okay, that's part A. Okay, part B, same concept. Okay, same concept for part B. I'm gonna give myself some room there. Okay, so I have a product. So I'm gonna say right there is my product, where the first term is 2 sine of x, the second term is cosine of y. Okay, so I am going to take the derivative of both sides, but in this case, taking the derivative with respect to x, meaning x is our variable and y is our function. So the derivative, the product rule said, the derivative of the first times the second, which would be cosine of y, plus the derivative of the second multiplied by the first, which would be 2 sine of x, is equal to the derivative of 1. Derivative of a constant is 0, no matter what you are taking derivative with respect to. Okay, so here the derivative of 2 sine x would be 2 cosine of x. Okay, and then the derivative of cosine of y is negative sine of y multiplied by dy dx, because y, we are taking the derivative of cosine of y with respect to x. So y is treated as a function in terms of x. So then we have to multiply by the inside derivative, which is dy dx. That is the concept of implicit differentiation. Okay, so anyhow, we are looking for dy dx, so put things on one side and things with dy dx on the other, and then somehow separate dy dx. So 2 cosine of x times cosine of y is equal to negative on the left. I add it to the right, so that would be sine 2 sine of x sine of y multiplied by dy dx. Notice how I reorganize my terms there, or my factors there, because that's multiplication. Okay, so the last thing to do is go ahead to divide. And 2 divided by 2, that would be 1. So we can say that that is no longer there if you divide both sides by 2, right? So dy dx will equal to cosine of x cosine of y divided by sine of x multiplied by sine of y. Okay, that is part B. Okay, part C. We have the derivative of, that looks like, if we were to graph this, it is going to be an oval shape. Okay, it looks like a circle, but not the same number of x's and y, so it's lopsided, so it's going to give an oval instead of a circle, and that's how I think of the shape of that that graph there. So we have the derivative of 9x squared with respect to x, and that's why it's important that we write with respect to x. Okay, so then the derivative of 9x squared with respect to x is 18x plus the derivative of 16y squared with respect to x. And we would think the derivative of 16y squared with respect to x. You see how the letters are not the same, right? So you think of y as a function in terms of x. So that is, y is an inside function. So it's like this, right? So then you move the exponent down. So that's 32 y multiplied by the inside derivative, which is the derivative of y with respect to x. Okay, so that right there is 32y dy dx is equal to the derivative of a constant with respect to any variable is 0. Okay, subtract and divide. So dy dx is equal to negative 18x divided by 32y. And you can actually reduce divided by 2 on both sides. That would be negative 9. Divide by 2 on the numerator and the denominator. Negative 9 over 16y. And that is your answer for part C. Now that I think about it, I should have written part C on top so that the progression of the level of difficulty would be a little bit better. Anyhow, so part C is a basic implicit differentiation problem. Part B actually is a medium size, and part A is a somewhat of a more difficult question. Okay, so that is implicit differentiation. That is one part of your exam 2.